welcome back. Today we'll start the new chapter number 3, metals and non-metals. Before begin this chapter, let us understand why we need to read this chapter, because our life depends upon metals and non-metals. From a small needle to a big aeroplane, they all are manufactured by metals. And the environment is surrounded by some gases. That gases are non-metals. So therefore we need to study the metals and non-metals because of their importance in our life. And one more purpose is for exam purpose. Let us define. This chapter includes physical comparison of metals and non-metals, chemical properties of metals, their reactions, and metallurgy concept is also there. We'll discuss all things in this chapter. Before this defining metals and non-metals, let us have a look on the periodic table. What here written here in this color metals, what here metalloids, and this color non-metals. So all what are those? These all are chemical elements only. Many of these chemical elements are metals, and some are non-metals. Least are metalloids. So metals, non-metals, metalloids, what are those? That all are chemical elements only. Observe here, like metals, we have lithium, beryllium, sodium, magnesium, potassium, calcium, scandium, titanium, chromium, iron, gold, silver, nickel, copper, zinc. That all are what? Metals. And non-metals, carbon, nitrogen, oxygen, fluorine, neon, helium, argon, xenon, sulfur, phosphorus, selenium, bromine, krypton, iodine, xenon. That all are non-metals. And this color metalloids, boron, silicon, germanium, arsenic, tellurium, plutonium, metalloids they are. So depends upon the properties of the chemical elements. We classified these chemical elements into 3 types: metals, metalloids, non-metals. So our topic is about metals and non-metals. Let us define the metals. Before defining the metal, let us have the electronic configuration of a metal. Depends upon electronic configuration, will define metal. What is this? Chemical symbol of sodium. What is the atomic number of sodium? 11. How the electron distributed in sodium atom? 2, 8, 1. Now potassium. What is the electronic configuration of potassium? Atomic number is 19. So electronic configuration is 2, 8, 8, 1. Calcium. Atomic number is 20. Electronic configuration 2, 8, 8, 2. Magnesium. Atomic number 12. Electronic configuration 2, 8, 2. One more element will take beryllium. Atomic number 4, electronic configuration 2, 2. Now let us define our metal. Depends upon the electronic configuration. Look at the last shell electron. 1 here in potassium 1, calcium 2, magnesium 2, beryllium 2. This valence electron, how many valence electron they contain? Either 1, 2 or 3. One more element will take as a 3. So any chemical element which have valence electron or last shell electron either 1, 2 or 3, that chemical elements are called metals. I will repeat, metals are chemical elements having valence electron or last shell electron, either 1, 2 or a 3. That chemical elements are called metals. Or we can define the chemical element which having a tendency, capacity to lose the electron, to donate the electron or to lose the electron and become cation. For example, sodium. Sodium, to satisfy octet condition, sodium will lose how many electron? 1 electron. When it lose 1 electron, it become a charged particle, that is a cation. How many protons sodium contain? 11, positive charge. How many electrons sodium contain? 11, negative charge. Total charge before losing 0. When sodium lose 1 electron, so electrons remains in the sodium atom will be 10. So what will be the charge here? +1. So okay. Similarly, potassium. Total proton we have 19 and electron 19. Total charge 0. When it lose 1 electron to satisfy noble gas configuration, it become a charge ion. That is, electron 1 electron loses, total charge +1. So depends upon this we can define again metal. How? Metals are chemical elements which having a tendency to lose the electron and become cation. That element we are calling metals.